I'm Ethan, and welcome to this Fun with Electronics video. In recent times, we've been stuck inside a lot, so I decided to make a cool project that included both programming, electronics, and building. Essentially, this project was an electric car that was controlled by a Bluetooth app. Once I got the idea for my project, and about a week ago, the first thing I did was make a general layout of how it's going to actually look. So I used Google Drawings to make it, mostly because it's very easy to use while also looking somewhat professional. As you can see, the Google Drawings is not very specific. It just has a general layout of where everything should be, and then it just labels them. After my Google Drawings, I went on to actually make a detailed list of materials. So I knew what to buy and what I already had, so I didn't have to go to the store multiple times or order things via Amazon multiple times. So I created a list of building materials, as you will see. So I needed 4 wooden wheels, straws to hold the axles, hot glue to glue the parts together, motors that provided the power to the wheels to make the car move, and the scissors to cut objects. I also needed 4 axle holes to hold the axles in place. I needed toothpicks and chopsticks to be the actual axles, which would be, well, what the wheels are attached to, and a piece of wood that would be the body of the car. Lastly, I would need gears to make the motor spin the wheel. After I finished my building materials list, I went on to make my electronics material list. As you will see, it's kind of a big list, and I'll go into what most of those electronics do later on in the video. After I made the list of electronics, I decided to make a list of the programs that I would use. The 2 main ones would be MIT App Inventor, which is in charge of making the Bluetooth app work and essentially make the buttons pressable. And then I had Arduino IDE, which was in charge of making the motors turn when a certain amount of electricity was put into them. The first thing I did was to cut out the body of the car from a piece of wood using scissors. Next, I hot glued the motors to the back of the car. Once the glue dried, I put on gears on both of the motors. Then, I glued the straw to the front of the car, and I glued the axle holes about 1/2 centimeter away from the motors. Then, I put the chopsticks inside of the straw, and I put the toothpicks through the axle holes. Then, I put bigger gears onto the toothpicks so the wheels could actually turn, and I put medium gears on the toothpicks to act as a barrier between the body and the big gears. Lastly, I glued all of the wheels onto the toothpicks and the chopsticks. And with that, the build was complete. In order for the car to work, one very important concept was used, which was called gear ratios. When using gears, there are 2 types, a driver gear and a driven gear. The driver gear is usually connected to the motor, while the driven gear is connected to the thing that we actually want to move, which in this case is the wheel. From the 2 gears, a ratio can be determined, which is the number of teeth on the driven gear divided by the number of teeth on the driver gear. The higher the ratio is, the slower the car moves, but the motors will be much more powerful. This ratio is exactly what my car used, as the driven gear was 50 teeth, while the driver gear was only 16. That made the gear ratio 50 divided by 16, which is 3.125. With the gear ratio, my car was a bit slower, but it was much more powerful, which meant it could actually move forward. Now, let's move on to the electronics. First, I decided to wire the motors in my car, using a breadboard, a battery, an Arduino, and an H-bridge. The Arduino is the brains of the operation. It basically is loaded with code, and then when I press a button in the app, it distributes electricity to the H-bridge. The H-bridge processes all the electricity, and then it actually gives it to the motors. And of course, when the motors get the electricity, they will start moving forward or backwards, and the car will obviously start moving as well. Then, I installed my HC05 module, which is a Bluetooth module that allows me to communicate between the Arduino and my phone app. Essentially, when I click a button on my app, the app sends information to the Bluetooth module, and the Bluetooth module uses Bluetooth to give it to the Arduino. Once the Arduino gets the information, it can of course start distributing the electricity to the motors. Now that the Bluetooth module is installed, all of the electronics is now finished. So now it's time to move on to the software. I used MIT App Inventor, which is a block-based code system that allows people to program apps. So first, I used the MIT App Inventor to figure out the layout of my app. I placed the buttons where they were supposed to be, of which I had 4 for moving around, 1 forward, 1 to the left, 1 to the right, and 1 back. And then I had a button to connect to Bluetooth. After I finished the layout for the app, I moved on to the block code portion of MIT App Inventor. Essentially all the code did was, based on the button I was pressing, a certain number was sent to the Arduino. The Arduino would of course interpret that data. The way the Arduino processes the data is by using if statements. So for example, let's say I pressed the left button, so that meant that the Bluetooth app would have sent a 2 to the Arduino. So there would be a statement that would say, if the number is 2, move the left motor forward, which would mean the car would turn left. There would also be an if statement if a 3 came in, which would mean that the car would turn right, and so on. So each different case, that's every possibility, would be covered by the if statements. After I finished coding in the Arduino IDE, I was completely done. So I was ready to run my car, and here are the results. I hope you learned a little bit about electronics, programming, and building in my quest to build an electric car. If you have any questions at all about how to build one, or in general, you can just email me at learn.electronics.projects@gmail.com. The link will also be in the video description. Also, if you want to watch any other videos that we put out, they will also be in the description. I hope you have a good day, and goodbye!